Hello, college algebra students. This is the first part of section 1.1 graphing equations. We're going to graph this first equation using a table. You may choose any points you would like for x. I'm going to choose -2, -1, 0, 1, and 2. Substitute each of those points into the equation and then to find the corresponding y. -2 squared is 4, minus 2 is 2. -1 squared is 1, minus 2 is -1. 0 squared minus 2 is -2. 1 squared minus 2 is -1. And 2 squared minus 2 is 2. Next, we plot those points. So -2, 2, -1, -1, 0, -2, 1, -1, and 2, 2. This is forming a parabola that is shifted down 2 units. Let me try that again. That's a little better, not much. That's supposed to be a parabola anyway. If you look at it on your graphing calculator, you need to go to y equals and clear out anything that's there, and then you can just type in x squared minus 2 and then graph, and that should show you your parabola. That one looks a lot nicer than the one that I drew. Okay, next page. Use your calculator to sketch the graph and find the x and y intercepts. So here's your calculator. Again, you're going to go back to y equals, and we're going to type in the first equation, x cubed minus 4x and so we have a graph that is S-shaped, and I'd like you to just sketch that on your paper. Next, we're going to use the calculator to find the intercepts. We need to find the x-intercepts and the y-intercepts. The x-intercepts are where the graph intersects the x-axis. So there will be 3 x-intercepts. In order to do that with your calculator, we're going to use the second key and then calc, which is trace, and then you're going to use 0, number 2. Move your cursor to the left of the 0. Press enter, then move it to the right of the 0. Press enter, and then press enter one more time, and the cursor moves to the 0, and so that x-intercept is -2, 0. The next one looks like it's 0, 0. Let's go ahead and check it. Second, calc 0. Move it so that it is to the left of the 0. Press enter. Move it to the right of the 0. Press enter, and then enter one more time. And that one is 0, 0. And now we'll find the third one. Second, calc 0 again. To the left of the 0, to the right of the 0, and so the final x-intercept is the point 2, 0. Next, we're going to find the y-intercept. The y-intercept is where the graph crosses the y-axis. In this case, it's going to be the same as the x-intercept. It will be 0, 0. To do that with your calculator, you will do second, calc, value and choose 0 for the value. And then it tells you that when x is 0, y is 0. So that's your x-intercept. For the next question, we have to begin by solving the equation for y. So I'm going to subtract x squared, which is going to be y squared equals negative x squared plus 25. Then we have to take the square root of both sides to get y by itself. Y equals plus or minus the square root of x squared plus 25. I'm sorry, there's a negative in front of that x squared. So it's negative x squared plus 25 underneath the radical. Now, when we graph this on the calculator, we actually have to graph both the positive and the negative equations. So first, I'm going to graph the square root of negative x squared plus 25. And so when you look at that, you can see it's a half circle. And now when we graph the opposite of the square root of negative x squared plus 25, that will give us the bottom of the circle. Now, my circle looks more like an oval. That's because my screen is set to go from negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis. But the screen is a rectangle, so it's more stretched out horizontally than it is vertically. To fix that, you can go to zoom and then number 5 z². That makes the intervals the same horizontally and vertically, and now your circle looks like a circle. These little spaces in between the circle, that's just a limitation of the calculator. I'm not sure why it doesn't connect right there. That's something to do with the software. So now we need to sketch that on our paper. And now we can find the x and y intercepts. For this problem, we do have a circle. The radius of this circle is going to be 5. If we try to calculate the zeros here, it's going to give us an error because these are two separate curves. So we can try second calc 0, but the problem is we're not going to be able to go all the way to the left because our curve stops there. So it gets confused. So we have to use what we know about circles, and we'll learn more about circles in a few minutes. But this, you can tell from the picture, the x-intercepts here are going to be positive 5 and negative 5. The y-intercepts we can do, let's go back to the graph and do second calc value. And when x is 0, it's going to give us 5 for the y-intercept. And then if we find the other one, we need to switch to the other curve, and I did that by pressing the down arrow. Second calc value, x equals 0. And, oh, it went up to the top again. Well, again, that's going to have to be a negative 5 because it's a circle. So this is going to be 0, negative 5. Sometimes you can find it in the table when second calc value doesn't work. So let's try second table. And those numbers are too big. Let's go smaller. And so right here, you see the points 5, 0, and 5, 0. Those are your x-intercepts, the y1 and the y2. Wait, let's think about this. The first curve was y1, that's the top part. So you have 5, 0, there's that point right there. And then if we go here at 0, 5, that's your y-intercept up here at the top. And then I believe if we go to negative 5, yep, there it is. Negative 5, 0 is your y-intercept down here. So sometimes you can get those intercepts off of the table if the second calc value doesn't work. In just a few minutes, I'm going to show you how to do it algebraically, so you won't even have to use the calculator. All right, let's do this last problem. Y squared equals x plus 4. Just like last time, we need to take the square root of both sides. And so y is equal to plus or minus radical x plus 4. Take a look at that on your calculator. So you need to enter both the positive and the negative, and then when you graph it, it's going to look like a parabola turned on its side. Okay, and then sketch that graph. Now let's find that x-intercept. Again, we're going to have to use the picture because these two are really two curves that are intersecting right there, and second calc value isn't going to work for us. So that is going to be the point negative 4, 0. And then the y-intercept here from the picture is 0, 2, and down here is 0, negative 2 for your y-intercepts. And again, you can see those in the table, or you could do, there's the 0, 2 and the 0, negative 2, and then there's the negative 4, 0. So the table is probably the easiest way to do those. Let's go ahead and go to the next page. Now we're going to find these same intercepts, but we're going to do it algebraically. In order to do this, we have to let x equals 0 to find the y-intercept, and we have to let y equals 0 to find the x-intercept. So let's start with the x-intercept. In that case, y is 0. And in order to solve it, we will have to factor. Take out the x, and that's x squared minus 4. And then x squared minus 4 is the difference of two squares. X minus 2, x plus 2. Then you set each factor equal to 0. So our zeros are 0, 0 for this one, 2, 0 for this one, and negative 2, 0. It's very important that you write your intercepts as coordinates. You will be counted wrong if on the test and the quiz if you leave them as x equals 2 or x equals negative 2. We're going to stop right there for this video, and the next video will continue where we left off.